Okay, so hello everyone. Welcome in my house. Yeah, that's my house basically. It's a new experience to do this in my house. Hello everyone. Thank you for having me. It's very nice to be here. So what will a whole nation do? That's the topic of today's presentation. So we will talk a little bit about psychology, about society, about artificial intelligence, about machine learning, and about combining these all things, these all elements into something that I personally find very, very interesting. And I really hope that some of you will also find it interesting. But first things first, let me introduce myself. I am Piotr Śliwa, principal software engineer at a wonderful company, Pragmatic Brains. That's the first part of my professional career. And the second part, and that's actually what I would like to talk about today, is being a lead researcher in the Institute of Organization and Management at Wrocław University of Economics and Business. So before I started my PhD, before I started the research project, a few people asked me, what fun can a software developer do in the university studying social sciences? So I thought it through for a little while. And so for starters, you must understand that socializing is actually a tool for social scientists, like a research tool. So it is possible there to work by partying hard. So that's a thing to do. That's of course a fun thing to do. But to me, because I am more of a papa bear than party man nowadays. For me, the most interesting thing to do was to build Skynet. Okay, let me change the screen. Oh, yes. So for those of you who don't know what Skynet is, I really encourage you to watch Terminator, the movie. It's a very fun one. But let me spoil it a little bit for you right now. So Skynet was the artificial intelligence that became self-aware and that took control over the world. And well, it tried to remove people from it. So that's rather awkward outcome of having artificial intelligence governing us. So we, with my research team, with the team I've been currently leading, we are not into it. Of course we don't want to achieve that, but we do want to transfer some of the control to the AI. So the question is, of course, why? Yeah, because we as humanity, we tend to suck at having control over other people. And based on our experience, our history, it's pretty safe to say that sometimes we're no better than Skynet, than the evil artificial intelligence from sci-fi movies. So we have greedy, naughty boys in our societies who sometimes tend to lead us. And yeah, there were a lot of occasions when it didn't end well for a lot of people, like a huge number of people. So the thing is that based on studies, based on the research, on psychological research, on how we do as humans, how our brains work, it turns out that we are incapable of making rational decisions. We are highly irrational creatures. So if you think about it, it makes sense, because the evolution, it hasn't prepared us for making rational decisions. It has prepared us for surviving in the wilderness, for procreating, for those kind of things, but it's not congruent to making rational decisions. It's not the same thing. On the other hand, to have a just, effective society, we really do need rational decisions. It's mandatory. For sure, we don't want to have decisions made for the whole society, made by someone who has, his own image of the reality, his own private bias. So, but to understand why our brains work like that, we first have to rewind to the very beginning of the cognitive process. So when we experience stuff, when we deal with stuff, with real stuff, we build a model of the surrounding reality in our heads. So depending on what data our brain gets, it builds more or less good reflection of the reality. So it's more or less, it's either a little bit better or a little bit worse reflection of the reality in our head. And our brain is only able to construct as good model as good data there was. So in this, we are no better than machines, actually. If you take the machine learning into consideration, and if you know how machine learning is, so how machines can be prone to different kinds of issues stemming from this fact, like underfitting, overfitting, yeah, and stuff like this. The same thing applies to humans. We are, in this matter, we are a little bit better machines. So after the successful cognitive process, we should have a good reflection of the reality in our head, a good model of it. And it's called the cognitive network. So it's a network of different concepts, abstractions, ideas, stimulus, all connected to each other that our brain can use to solve different cognitive tasks. So if you are asked if a hamster can hear, what your brain will do, it will jump around different concepts. It will try to find the concept that will allow it to tackle this task. So for example, here, it will jump from the hamster to the concept of ear, because, well, based on our knowledge, the hamster has the ear. And from the ear to the concept of listening, which is of course connected to other concepts as well. And the important thing is that the task of association, so jumping around different contexts and connecting the dots, is a process that is compulsive. Compulsive meaning we don't have full control over it. And it also makes sense in regards to evolution, because if you walk in a jungle and you see a snake just at the very edge of your sight, what your brain will do, if it's correctly aligned to the situation, it will connect the dot, like the stimulus of vision at the edge of your sight, and it will somehow connect it with the danger. So it will make you aware of the danger, and if the danger is very vivid and it's projected well in your brain, it will make you run away or just be aware of this danger. So it's very, very needed for us surviving in the wilderness. So to show you on a real example, so that you can see it on yourself, on your own brain, how does it work, the compulsive association, I would like to show you a picture that you probably know, this picture. So depending on how easy it was to get for your brain, the two different concepts, either the concept of a duck or a concept of a rabbit, those two concepts were somehow connected in your brain, in your cognitive brain. They were embedded in your cognitive brain. And depending on what was easier to summon for your brain, you either first saw a duck or a rabbit. And to visualize the compulsion, the process of learning, of connecting dots, how your brain do it, let me show you this picture. So this is, okay, this is just a word, right? Unless I tell you a story about Bob. So this is Bob laying on the grass, looking at the sky. He's very happy because he's just returned from work and he doesn't have anything to do, and it's nearly weekend. So he loves it. He loves it, lying on the grass and just looking at the sky. He's smiling. He's bald also, but he's smiling. He has no shoes. He has actually no clothes. He lays naked on the ground and is looking at the sky, and he sees a wonderful bird which just passed by. He's looking at the plains, at chemtrails. Yeah, he's very nice. It's like wonderful day for Bob. So if you've listened carefully to this story and you've imagined the whole thing, when I show you this, the first thing you should be looking at is a few people laying on the ground. Of course, after a few seconds, your brain will probably adjust to the situation and will tell you that, okay, these are not people, these are just okay words. But yeah, that's how it works. Because each of us has his or her own projection of the reality in our head, and it's the only thing that we can reason about. We cannot reason about the real reality. We can reason about only the model of the reality in our head. Because of that, if you ask a person what a tree is, she may respond that it's just wood, it's nothing else. If you ask someone else, he may tell you that this is the danger because he has a very vivid memory of a tragic accident that he was involved in, and the tree was involved in it too. If you ask another person, he may respond to you that the tree is actually a divinity because he really believes that the God himself lives in trees. And as a collective, we tend to agree on a lot of stuff, which is really, really good. If you ask a collective, if you ask every one of us who is here, who's listening to this presentation, what tree is made of, most of us will probably respond that it's made of wood. Yeah, because that's, as far as we know, this is made of wood, and it's just, this is as important as it gets for us. We don't have to delve into what's the inner structure of the atoms and what's other thing that it's made of. The general concept of wood is usually enough. But unfortunately, we also tend to agree on things that are not really there. They're on incorrect interpretations of the surrounding reality. And one of the most evident things, one of the most evident biases that we have, is our inability to assess risk. And it's so evident, actually, that the whole insurance industry is based on it. And as we know, the insurance industry makes like billions of dollars each year. So how it works, if you buy an insurance for €100 and your insurance company promises you that it will pay you back €100,000 if you participate in a kind of accident, then you can be pretty sure that if you measure the real possibility of you having such an accident and you weight it by the €100,000 that they promise, you can be pretty sure that it will be way below €100. It's how they make money. They charge you a little bit more than it is the real value of the insurance. And we all buy insurance. Of course, there are other aspects that we also tend to follow. But yeah, this is how it works. Another interesting case of us overestimating risk was the very beginning of the coronavirus pandemic, right? When we had like just a handful of situations in the whole country, and even though everyone was paranoid about wearing masks, about not connecting with each other, and staying home and things like that. So if you asked a person, an average person, what's the probability of you getting the disease, but back then, you would probably get much higher estimate than it really was there. Of course, we also tend to underestimate risk on other occasions, especially when we really want something to happen. So it's like when you have a project, when you estimate your task, you probably remember situations when you estimated it for 1 day and it really took 10 days, for instance, right? Another example is the whole startup industry. Like the recent study showed that over 90% of startups fail within the first 24 months of their operations. So it's like, it's businessly speaking, it's like very, very low risk of high risk of failing. And even having that in mind, a lot of people invest their life savings, their lifetime. They devote a lot of things into a project that will probably fail. And it's not uncommon to see professionals, to see experts making hardly good decisions because of their biases. Like we saw politicians making stupid decisions. We saw specialist experts from the financial sector that decided in a way that caused actually the whole economic to have multiple crises. And of course, it's also the same thing for the whole advertising industry. So a lot of companies assign a concept either of happiness or some kind of coolness or any other tag or label to their products. And as we know, a lot of people buy the products just because of that, to feel this promise, to feel it, to just have it. And it's this one is actually very, very dangerous for our democracy. I believe that a lot of us remember the case of Cambridge Analytica, the company that existed a few years back and meddled in the voting campaign, in the presidential campaigns in Trinidad and Tobago, and later in the United States of America. And so what they did is actually they profiled a lot of people, like the whole society, and they found what was the fears, what was the anxieties of certain people, and they targeted a content that either made these emotions higher, like it intensified them, or promised to mitigate them given their specific actions. So the whole thing, all of our inabilities of interpreting the surrounding reality, if we sum it up, all of it was, so to speak, invented by two fine researchers from the psychology area. And Daniel Kahneman is the guy here, and Amos Tversky. They worked together and they mined the concept of cognitive bias. Daniel Kahneman actually won a Nobel Prize a few years back just for the research. And since the researchers came up with the idea, other researchers have proven like hundreds of different kinds of cognitive biases that people has. And the list is surely not limited. It's not exhaustive. And because our brains evolve very, very slow, because the evolution works very, very slow, and the surrounding reality changes very, very fast, we do expect the list to become greater each year. So having this in mind, having our inability to make rational decisions, what can we do? What's our approach to deciding for society? Can we do dictatorship? Well, no, that's not the case. That's not the case here, because given what we've just said, if we gave control to just one person, we risk a lot, because the person may have very distorted model of the reality in his or her head. So it's like, it doesn't make sense to make the decisions by one person. So of course it's not an option. Democracy is cool. It's a very nice system, but it's also prone to these kinds of errors, because if we aggregate a lot of different cognitive biases, there are a lot of things like our inability to estimate risk, which when we aggregate it to the whole group, we are still prone to it. It's the same thing like the example of coronavirus disease. If you ask the people there and you took an average from the whole group, you would probably still get like much higher estimate that there really was. So we are, as a group, we also don't make rational decisions. Anarchy, yeah, at this point, we live in so globalized work, and we are so used to the fact that we can do anything, we want, anytime we want, and get anything, basically, that, yeah, at this point, it doesn't seem to be an option too. So what's the cure? Well, we, with our team and other teams, we believe that there is a cure, and that's why the program Algeria was initiated. So Algeria was a nymph attributed to a legendary role in the early Roman Empire. She was a counselor and consort of the second king of Rome. So program Algeria is a research program that consists of multiple research done around the globe. And the main objective here is to create a system that will enable us to keep our democracy, but we will pair up with the AI to overcome our cognitive issues, so that we are able to establish like a common ground in interpreting the reality, to overcome our cognitive issues. So this solution, or this system that we are building, we are trying to find out. It will consist of multiple tools. There are units of monitoring, forecasting, and simulating. So these are the three main components. And the team, my team is working on the unit of the forecasting unit. So in order to start the whole research, we needed a theoretical foundation that we can base our whole model on. So we used the Bourdieu's field theory. Pierre Bourdieu was a fine French social scientist. He lived in 20th century. Well, his work was focused on the societies, and he presented the societies as so-called power fields. I won't delve into the details because it's not relevant to this presentation right now. But the important thing is that Bourdieu presented the whole socio-economic world as a social interaction. So everything that happens in socio-economic world is a social interaction, which is very interesting if we thought about it, if we think about it. Because if you take ownership, so you have a car, and this car is yours, only you can drive this car, no one else can do anything to this car but you, and you decide about its fate. So if we think about it, it's not like the car is somehow connected to you physically. There's no such thing. The whole thing that prevents other from using your car is just a social interaction with them. You form some kind of a relationship with all the people that prevents them from using your car. And the same thing goes to basically anything that we can imagine as a social economic activity. The same thing goes for money. So the $100 that you have in your pocket, it's, well, as a piece of paper, it's not really worth the thing that we believe it can buy you. So it's also a kind of social agreement that the $100 will buy you the things you want to buy. So that's our model. We try to model the society as a network of different kinds of relationships. We do this by, we use diverse data sources to gather information that enables us to create the network. We use social platforms like Facebook, Twitter, other platforms on the internet. We also prepare it for other kinds of data sources, but right now it's enough. So as a result of the network mining, so-called relationship mining, we get feature vectors of the relationships. So nothing unusual here. There are long vectors of floats that describe the whole compound relationship that connects the two people. So it's like, it's everywhere. It's basically everything there. It's the financial things, it's the ownership things, for instance, it's all kinds of stuff. We cannot really denote it with one word, like, okay, these two people, I don't know, love each other, or has a kind of effective relationship that, for example, prevents another people from doing something to this person. But it's a feature vector. So as a result, to have the model of the whole society, like the whole subnetwork that we are investigating, we end up with a adjacency matrix, which we probably all of us know. So the adjacency matrix, it consists of 3 columns. It's a tabular representation of the graph. So the first one is the origin of the edge. The second one is the target of the edge, which, of course, in this context, these are the 2 people that are interconnected by a relationship. And we have the feature vector that denotes the whole relationship that connects them. So our base assumption is that in order to have a network even propagation prediction model, so to predict any socioeconomic activity that happens in the society, in this part of the society, we need to have the influence propagation model and link prediction model. So influence propagation, what is it? This is basically the theory that I described to you, the base model, drawing upon Bourdieu's model. So this is the assumption that the whole society can be modeled, can be projected as a multi-graph of different relationships interconnecting all of the people, all of the participants or nodes. We can use, and we do use it, the other unit that is responsible for creating the monitoring tools for Algeria. They use it for analyzing statically the structure of the society. So given a snapshot of the society at a given time, they can, for example, look for clusters of relationship that characterize people who are, for example, heads or leaders of different cliques, like terrorist groups, for instance. So they look for it and they try to find similar relationships, like similar clusters of relationships, because keep in mind that the relationships are here just the feature vectors. So they can be interpreted as a multidimensional vectors, well, one-dimensional vectors. So we basically can find vectors, similar clusters of different relationships. So we can find similar relationships and try to find out who the leader of a different subnetwork is, who has the so-called hierarchical relationship connecting with other people. So then the link prediction. So link prediction is something that is already there in the machine learning area. It is the model that allows you to predict what will be the future state of the network. So in our case, it's the prediction of the future snapshot of the society. So in time t0, we have some relationships connecting the focal person here, and in the t1 we have different kind of relationship that he, as the person, formed with other people in the society. So how do we do it? Well, everyone, like every analyzed person, has a classifier. So here we have the classifier of person X, and in the training phase, we feed the classifier with other people's ego networks. Ego network is a list of feature vectors. In this case, it is the list of other relationships that the person formed. So it's like a profile of this person, but based on whatever relation he or she has formed. And given that the relationships in this model are everything that happens in the socio-economic world, so given that we have the profile, the socio-economic profile of a person, and we feed it with the focal person's classifier. And on the end, depending on the model, in the basic model, we just have a binary data, which means that either the person, either the person X forms a relationship with person A, which will be 1, or not, which will be 0, because we also take all other people into consideration and feed and train this model with either formed relationship or not formed relationship. But it's just a basic model to prove the concept. In the advanced model that we are currently investigating, we try to go a little bit further. So instead of having just a binary data that denotes the existence or not or inexistence of a relationship, we try to also grasp the class of forming relationship. So is it a hierarchical relationship? Is it an affective relationship? Is it a other kind of relationship? So we try to have different class of relationship that forms between the two people. So Algeria consists of multiple steps. Of course, it's a huge project. It cannot be done in like 1 year or 2 years. So first we had the preliminary research. It was phase 0. We had to confirm various hypotheses before we even started. We could include all the kinds of supporting research that was done prior to this program, like the Kahneman's work, like the Bourdieu's work and everything. So it's the phase that actually continues, that is continuously done, because we sometimes land up in a place that we really need to find out if our hypothesis about how the society works is true or not. And this is the phase that we are currently in. We try to develop so-called, well, we can call it proof of concepts. So our team is working on the network event forecasting. The other one is working on the network evolution monitoring. So this is the static monitoring of the network. In the phase 2 that we hope to achieve in 1 or 2 years, there will be a pilot, like incognito application of the program in one of the founding institutions. And then we hope to come up to the phase 3, which will be the large-scale application. And this will probably take much longer than the previous phases, because we also expect to align the system, so to speak, to the whole to the new standards, because there are a few institutions that are going to be impacted, and yeah, we need to scale that up to cover them. Yeah, as you can imagine, because of the rather sensitive subject that we touch upon with this program, it's rather kept low profile, but because it basically we basically need the sharpest brains on the planet in order to shape the reality. So yeah, right now we're looking at you, at software developers. So if some of you is interested in the research, would like to know something more, or maybe you would like to participate in the endeavor, I of course really encourage you to contact me. You can use my university mail. It's piotr.śliwa@ue.wroc.pl. So yeah, looking forward to hearing from you. Thank you very much for having me here. It was very nice to be here. And yeah, oddaję głos do studia. Thank you very much.